Hi, and welcome to question 7 of the 2023 paper 1 for the Leaving Cert Ordinary level. If you want to copy these notes, just send an email to shanetroy@gmail.com and like and subscribe to get access to more playlists. So question 7 here starts off with a 10-parter. Now it's a 10B, so there's a lot of marks for the attempt in this particular question. So it says, when it rains on land, some of the rain soaks into the land and the rest runs off the land. The runoff curve number C is a number used when estimating the amount of rain that runs off a particular area of land. Wow, we love our words. C is given by, okay, we have this model of this particular scenario. So in reality, all of this doesn't matter. This is all that matters. Okay, so C is the amount of rain and S is the maximum amount of rain that it can soak in. Now, part 1 says, find the value of C when S is equal to 15. So I'd always start off with like literally writing the model out or the equation out, just to get your brain thinking. I probably should write properly on the page. So if, as I write that, I notice there's two letters, there's two unknowns. Now I can't solve an equation of two unknowns. I can rearrange it, I can do whatever I want using algebra, but I can't solve it unless I'm given more information. Thankfully, I was. So I'm told one of the unknowns. So now this is an equation of only one unknown. The S is 15. Now I can do that by hand if I want, or I can go use the calculator. Now I don't have my calculator open. So 25. So in essence, that's asking how many 25s are there in 1,000? Okay, and you can count it up if you want it. Okay. Or you could have prepared in advance, and I got 40. And that's really what it is. So it's a good 10 marks. Okay. Any attempt at putting the 15 instead of S is going to get you up to the 7, which is a huge chunk. And then it's just a matter of using the calculator and popping off to the 10. There's no units. It's just straight through. Now, A part 2 says, when S increases, does C increase or decrease? Then it says, justify your answer using this equation. Okay. Now, if S gets bigger, what's going to happen to this number on the bottom? It's going to get bigger. So if we tried it, like we had it with 1,000 over, what was it, 15 plus 10 was 25. Now, if I said 1,000 divided by, let's say 20 plus 10 is 30. Now, if you run that through the calculator, 1,000 divided by 25 is going to be, what was it, 40? 1,000 divided by 30 is going to maybe be, I'm going to say 37. What is different between these two numbers? This is smaller. Okay. So the answer is simple. You just have to phrase it right. And that's always the part that drops off for me. So I'm going to say that it decreases. So I'm going to make a call. Now, even if you didn't know the answer and you got a two choices, it's a 50-50, roll the dice. So the justification I have here is as S gets bigger, the number on the bottom gets bigger, thus decreasing C. And I give an example now. I picked 75, not 20. And I just did and showed that that's 10. I maybe could have been a bit more clear and shown the original calculation, although that is in part 1, so it can be argued to follow through. And that's part 2. Now, part 3 says rearrange the equation to write S in terms of C. Okay, so let me go back and get this. C is equal to, okay, so C is equal to 1,000 over S plus, I don't know why that thing happens sometimes. Okay, S plus 10. Now I'm going to not make the mistake of not checking because I know myself. No, okay, I was right. So this, I want S to be on its own, everything else on the far side. Okay, I'm not trying to solve anything I can't solve. It's an equation of two unknowns and I don't have enough information. But I can show my skill in using algebra. Now, there's different ways to approach algebra. As long as you're consistent you're never going to be wrong. And the consistency involves doing the same thing to everything on both sides. Okay. So in this situation, I see, well, the S is on the bottom. Okay. So like, I don't particularly like that. Now, I'm going to do this a kind of weird way, just because it's something I think is unique. And you'll hopefully see the logic of what I'm doing. Okay. So I can always express something slightly differently. So the C there could be expressed as C over 1, because anything divided by 1 is itself. So it's not how it was presented to me, but it's how I want to present it. And I'm going to rewrite what's on the right-hand side. Now, this might not be the way I personally do it, from the way I suppose I learned. But if I turn this upside down, okay, I end up with 1 over C. Now, I'm allowed to do that as long as I do that to everything on the far side. Okay, now 1,000. And I don't make a mistake writing it. Now, you could argue, why would I do that? Okay, well, I got S on the top, and it might have been a slightly easier way of doing it. Okay, and that is a correct relevant step. Okay, so you're up to the low partial. Now, I want the S on its own. So this divided by 1,000 here, like I'd be tempted to move the plus, but because all of it's been divided by the 1,000, I should reverse that first. Now, the simple way is I can create situations. If I can create a situation where I have 1,000 divided by 1,000, well, anything divided by itself is 1, so I've gotten rid of it. Okay, so if I create a situation where I multiply the top by 1,000, I'm just going to pretend for the second. Okay, and I'm going to ignore that line going across. If I'm okay to do that, as long as I do it to the other side. Okay. Now, the reason I did that was to create this situation. So so they cancel. Okay. So you're left here with just the S plus 10. So it's simpler. Now, on the far side, I've created a problem. So, well, if I'm multiplying a fraction by a number, you always multiply with the top only. So it's 1 times 1,000 is 1,000 over C. Now we're almost there. Okay, if you can see it, all that's in the way of me now is this plus 10. Well, look, if I have €10 and I want to get rid of it, I suppose the easiest way to do it is to take 10 from it. 10 take away 10 is nothing. Now, if I do that to one side, I have to do that to the other. And that's the consistency of algebra. Okay, now I've probably written that badly. It'll be 1,000 over C is equal to, bloody hell. I'll try not to curse on a YouTube video. Is equal to now S, but the plus 10 over here has been removed, and the minus 10 is there. So I made it look like it was all on the top. So you're taking 10 away from this fraction, okay, and you're taking 10 away from this side. So 10 take away 10 is nothing, and that should be represented that way. And that's the answer. Okay, now I've done it a slightly different way here, in that in this, I suppose, attempt at it, and it's the same thing, it's just a different strategy. To get rid of this S plus 10, I've created the situation of multiplying the top by S plus 10. If I do it one side, I have to do it both sides. And then that situation would look, if you wanted to represent it differently, could look like this. And it's more obvious that anything divided by itself will cancel out. Now, on the far side, I've written it just in brackets to make it represented a bit more obviously. So once they've cancelled, I'm left with this statement, which is simpler. And then I go, well, I want to get rid of this C. So if I divide the left side by C, they will cancel. Okay, now if I divide the left side by C, I have to divide everything on the right side by C. Once they cancel out, you're left with this slightly simpler statement. Okay, but I'm not yet there because this 10 needed to be removed. So I took 10 away from it. If I do it one side, I have to do it both sides. Did the actual removal of them, okay, just got rid of them, and then you're left with your statement. And this equation is written in terms of S. Yeah, okay, or yeah, I'm not sure how that's phrased. And that's part 3. Okay, so part 4 here Okay, part 4 says the values for C go from 30 to 100. Use your answer from part A3 or otherwise to find the range of values of S. So look, let's get the answer from part A3. So that was this answer down here. So S is equal to 1,000 divided by C, take away 10. Now that could qualify you for an attempt. And I'm just going to take, even though it'll lengthen the video, I have it open on the other screen. Yeah, the low partial, 4 marks for just writing the answer from part 3. Happy days. Okay. Now the question says that the values of C go from 30 to 100. Okay, so that's your input. Your output or your range of values are generated from that. So if I put 30 in for C, okay, so that's 1,000 divided by 30, take away the 10. That's going to generate me an answer. Okay. Now, if I also do it for 100, okay, so 1,000 divided by the C value of 100, okay, take away 10. Now that's going to be, drop the zeros. That's not, am I doing something wrong? Let me check the answer here. Oh no, okay, I was right. So they're just done it digitally, whatever. The answers go from, I suppose, 0 as far as 70 over 3. And that's it. Okay. So a good 10 marks there. Just if you don't know what you're doing, throw the numbers in. Okay. If you're told what the equation is, happy days, you got marks for that. Throw those two numbers in. You'll get these two things. You mightn't even know what to write down here, but this should qualify for at least really good marks, if not the full marks, because you have it on the page. So then 7B part 1. So over the course of one day, now they're telling us that it's 24 hours, which I don't think is not an unreasonable thing to do. It happened a few years ago at a different exam, whatever. And a lot of students were asked something to do with the number of weeks in a year, and they just went 12 times 4 is 48, and they used 48 as being the number of weeks in a year, which it is not. It is 52 weeks in a year. Now, I can totally understand the logical thought process they had, or illogical in reality, but just, I mean, I suppose they followed a strategy, but it's kind of, you'd argue that's innate knowledge, but maybe not. So 24 hours in a day. The probability that it is raining in Waterville, P over T, so that's the probability of it raining. So the whole thing, so I always write this personally as, if I can, like that, to show that this subscript is just a descriptor. So the T is the input, okay, the POT is the output. That's the answer. Or in one way, now maybe not with this question, but you could always think of that as being your Y value. Okay, so your input, your output, your X, your Y. In this case, your T, your P of T. Okay, so then they give the model of the function. So it's linear. There's no power on the variable. So this will be linear model. Okay, it's got a slope of 0.02. So all these things would probably be useful in fairness. And it says the P of T is the probability that it is raining T hours after the start of the day. Okay, and then that range, or sort of, I suppose, whatever values, T values go from 0 as far as 24. So this coding here, you could ignore all of this. Okay, it's kind of irrelevant to the question to a certain extent. They're just setting the parameters in mathematical language. So I'm going to do as I always do. I'm going to rewrite the model. Okay, 0.3 plus 0.02t. Now from that, okay, I look, if you know more about linear modeling, that 0.3 is where it crosses the y-axis, the y-intercept, and then the number in front of the variable is the slope. So it's got a very small slope, so it's going up steadily, okay, not very dramatically, and it's very close to the origin. You see that if you graph it, but you don't have to graph it, but having an understanding of that is always very helpful. Now, write down the probability that it is raining at the start of the day. Oh, they're being really explicit. That is, find the value of P0 and P24. That seems pretty straightforward. So I've just done it here. I've put 0 in instead of the input. So I found P of 0. The T is the 0. Put that to the calculator. I got 0.3. and then that'd be a 30% chance. And then I did it again with 24, just like they asked me to. Okay, the same methodology, and then I got a p of 0.78. Now I generally leave probabilities in decimal form, okay, because probability score between 0 and 1, but 39 over 50 is between 0 and 1. It's just, again, it's normally written as a decimal. I looked at the marking scheme to see if I was being penalized if I left it in fraction form, and I couldn't see anything. And I don't think you would be, because again, it's the same number and they didn't explicitly ask for it to be in decimal. Now, the next one here, part 2, says find the value of P of t, the derivative of t, and explain what the value of P of t means in this context. Now, so the derivative of pt, now, I suppose this is a really direct hint, although this terminology might not be as familiar, but if you see derivative, it sounds like differentiation. And if you're not sure, you might as well go ahead and differentiate. Okay, so there's the equation. Now, if you differentiate 0.3, any number when differentiated always turns into 0. Okay, so it drops away. And then this number here has a power of 1. So the power by the number in front, 1 times 0.02 is 0.02. And then you take 1 away from the power. So 1 away from the power, t to the 1 take away 1 gives you t to the power of 0. Anything to the power of 0 is always 1. So that 0.02 times 1 is what this t ends up being. Now, anything by 1 is itself, so the answer is 0.02. Now, what does that mean? Well, derivative of pt is the slope. Okay, that's what it means. That's why we do it, is to find the slope, which is the rate of change. So the slope measures the change, and a positive slope means that there's an increasing trend. Okay, or put it more explicitly for this example, the probability that it is raining in Waterville is increasing at a rate of 0.02 every hour. Or if you turn that into a percentage, 2%. Multiply 0.02 by 100 to get your 2%. There's different ways of saying the same thing. It's just however you want to phrase it. So as long as you're phrasing it in a way that makes sense and that another human being can understand, you should qualify for the marks. Okay. Now, B part 3 says, at a certain time, the probability that it is raining according to this model is 0.35. So the probability is 0.35. Now, if you turn that into a percentage, 0.35 by 100 is 35%. Now, that might qualify for an attempt. It just depends on the marking scheme and the interpretation of it, okay? But it's something, it's correct. You're trying to make sense of the question. Now, that's not even chance. So like, there's a chance of it raining, okay? It's a little over a third. I understand, okay? Now it says, work out the probability that it is raining exactly 1 hour later according to this model. Now, this is actually a surprisingly tricky question. And probability questions they can, in my mind, be seriously easy, but I think they're being really hard and tricky, and then I overthink it. Or they can be like what seems really hard, okay, and I underthink it. So I think that's right around. So if you think about it, at a certain time in the day, the probability of it raining is 0.35. Now we have a statement of the probability. It's P of t is equal to, what was it, 0.3 plus 0.02t. Now they're saying that the probability is 0.35. Actually, let me just use the answer. Okay, so that's where I was. Okay, that's our original model. They're telling me that the P of t is 0.35 at a certain time. Well, I don't know what time that is. Okay, but if P of t, if these two things are equal, and this is a really important concept in maths, and oftentimes questions are testing your ability to understand this logic. And if you do, because you do the rest of it, that's proof of it. Okay, so if these two things are equal, doesn't it mean that the two things on the right side should be equal? And it does. And that's what the logic. Okay, if you can grasp that and demonstrate that, you've proven that ability, that skill. You have that ability to think that way. Now, once I realize that, I write them out. And here you are, you're flying. Okay, And there's only 5 marks for this question, so you're definitely on the 3 because you've made that logical leap. Now, when I have an unknown, an equation of one unknown is solvable, I might as well solve it. Okay, even if I don't know why I'm doing it, I might as well. Okay. Now to solve this, I want the t on its own, so I'm going to take 0.3 away on the left side. Okay. If I do it to one side, I have to do the same thing to the far side. Now, once I do something, I have to do the arithmetic. 0.3 take away 0.3 is gone. It's nothing. Okay. So I'm left with 0.02. On the far side, 0.35 take away 0.3 is 0.05. Okay, again, calculator. And then I go, well, I want t, not 0.02 times t. Okay. The one way to get rid of something is to divide it by it. Okay, so if I divide 0.02 by 0.02, they will cancel and turn into 1. Okay. Now, if I do it to one side, I have to do it to everything on the far side. So they cancel. On the far side, 0.05 divided by 0.02 is 5.2, or you could say, what's that, 2.5? Okay, 2.5. Now, that was great. If you got that far, you definitely have the 3. You're not on the 5 yet because we're a little bit away. It says the question is asking us to work out the probability that's raining 1 hour later than this probability. We use that probability to find the time for it, which was 2.5 hours. Now, 2.5 plus 1 is the next time. Now, that's 3.5. And once you make that leap, I know that the t value for that time is 3.5, and I can put it into my p of t. Okay, substitute it in instead of t, and then generate the answer, and I got 0.37. Okay, now there's a lot of fair bit of maths there, and I had to represent it, but if you've gotten to that stage, you're well capable. This is, I suppose, a triple layered question, making this leap here, then doing the algebra, and then making the final leap to exactly what the question is asking, and then finding out that actual answer. That's a lot of steps. Okay. Now, question 7b is a long question, and leading into 8 and 9, whatever. So sometimes it's a good time to take a break. Maybe that happens between question 6 and 7, because that question's full on, and probability can be very mentally to whatever. So if you have a drink with you, it's maybe time to make sure you've taken on some liquid, and if you've brought in any fruit, whatever, some carbs, maybe now is as good a time as any. Okay, so that's the question 7. If you want to copy these notes, send me an email at shanetroy@gmail.com, and like and subscribe to get access to more playlists. See you on question 8.